In this video, we're going to be looking at solving more simultaneous equations by elimination. In the previous video, we looked at solving simultaneous equations that look like this. Pause the video and make sure you are comfortable solving this kind of problem before continuing with the rest of this video. If you're not sure about how to do this, you need to go back to the previous video and watch that. Okay, here's how I would solve this. I would add the left-hand sides of the two equations. 3x plus 4y plus negative 3x minus y altogether gives me 3y. The big idea here is that the 3x and the negative 3x eliminate. They are a zero pair. They add up to 0. And the 4y and this negative y add up to 3y. So we've got that on the left-hand side, and that is going to be equal to 25 plus negative 22. When I add those together, I get positive 3. And from there, it's quite easy to see that y must equal 1. Now, we haven't finished solving these equations simultaneously. We've only found the value of y. But what we've got here are two equations with two unknowns. We need to find the value of x and y. So what we can do is take this value of y and substitute it into one of these two equations. Now, it doesn't matter which one you pick, but I like to go for the easier one. In this case, that's the top one, because the second one has got some nasty negatives in it. So, substituting y equals 1 into this first equation, we get 3x plus 4 lots of y, which is just 4 because we know y equals 1. That's going to equal 25. Now, to solve this for x, what I need to do is subtract 4 from the left and the right hand side. That gives me 3x equals 21. Now I can divide each side by 3, and that gives me x equals 7. So my solution set is actually x equals 7, y equals 1. Now, the examples we're about to look at are going to involve one extra step at the beginning in order to turn those simultaneous equations into ones like we've got here, as you will see. Okay, let's get into question A. We've got this pair of simultaneous equations. However, we have a problem. Look at what happens if you try to add these equations together. Pause the video and have a go at adding them and see what problem you run into. Okay, if we add the right-hand sides, we get 15 plus 19, which is 34. And that's going to be equal to what we get when we add the left-hand sides. Now, x plus 2y plus x plus 3y gives us 2x plus 5y. Now, this is a correct equation based on these two, but it doesn't help us because we've still got an equation with two unknowns. And in all our previous examples, when we added the pair of equations together, we always managed to eliminate one of the unknowns, either the x or the y. And doing that made it easier for us to solve the equation. In this case, adding doesn't help us. That's because neither the x's nor the y's form a zero pair. So here's what we can do about it. What I can do is look to see if I've got the same number of x's or the same number of y's in the two equations. Now, in the first one I've got 2y and in the second one I've got 3y. So they don't really match. But in both equations I've got 1x. That means if I multiply one of these equations through by -1, then what I'll end up with is a pair of equations that I can just add together and will eliminate one of the variables. Let me show you what I mean. What I'm going to do is take the first equation and multiply all of it through by -1. So I'll have -1 lot of x, which is -x, plus -1 lot of 2y, which is -2y. So I'm going to have plus -2y. Now that's a bit complicated, so I can just change that into a -2y. And that's going to equal negative 1 lot of 15, which is just negative 15. So if this equation is true, then so is this one. All I've done is multiply the left-hand side by negative 1, and then to keep the equation balanced, I've multiplied the right-hand side by negative 1. So this is a true equation based on this one. What I'm going to do is just take this equation and leave it as it is, but write it underneath the other one. So I've got x plus 3y equals 19. Now, do you see how we've turned this pair of equations into ones where we can add them together? Hopefully you'll notice that the negative x and the x will eliminate when we add these two equations together. Let's do that now then. I'm going to have negative x minus 2y plus x plus 3y. The negative x and the x eliminate. The negative 2y plus 3y gives me positive 1y, or just y. And that's going to equal what we get when we add these together. Negative 15 plus 19 equals 4. So we've worked out the y value. Now we can substitute this in to any one of the equations we've got to find x. I'm going to use the one that's immediately above it. So I'm going to have x plus 3 lots of y, so 3 lots of 4, which is 12, and that must equal 19. So that's x plus 12 equals 19. And solving that equation, I get x equals 7. So our solution set to this pair of simultaneous equations is x equals 7, y equals 4. And remember, we can always check our solution set by substituting in these values into the two equations and making sure those equations are satisfied. For example, using x equals 7 and y equals 4, that means x plus 2y is 7 plus 2 lots of 4. Well, that's 7 plus 8, and that does indeed equal 15. And similarly, if you substitute these into the second equation, you'll find you get 19. So that means we have got the correct answer here. So what we're doing is exactly the same as what we were doing in the previous video, except we are first multiplying through one of the two equations by negative 1 in order to form a zero pair. Now, it doesn't matter which one of the two that you multiply through by negative 1 for these examples coming up. However, one of them will often be a bit easier than the other. For example, by choosing this top one to multiply through by negative 1, I ended up with a positive y equaled 4. If I did it the other way around and kept this top one as it is, but multiplied the second one by negative 1, then when I added the two equations together, I would have got negative y equals negative 4, and it just would have been a little bit more work. So you can try to be a little bit smart about this. Let's have a look at the next question. Here's question B. We've got negative 2x plus 7y equals negative 43, and negative 2x minus 4y equals 34. And you will find if you add these two equations together, you do not eliminate any variable. In fact, what you would get on the left-hand side is negative 4x plus 3y. So we have x's and y's in that. However, what's quite nice about this pair is that you've got negative 2x here and negative 2x here. So if you multiply one of the equations through by negative 1, then you will end up getting a positive 2x in that equation. And then when you add it to the other equation, the x's will eliminate. Now, I recommend that you multiply this equation here through by negative 1. That means we're going to keep the top one just as it is. So that's negative 2x plus 7y equals negative 43. I haven't changed that equation. But this one here, multiplying through by negative 1, I'm going to have negative 1 lots of negative 2x, which is positive 2x. And I'm going to have negative 1 lots of negative 4y. So that gives me plus 4y here. And that's going to equal negative 1 lot of 34, which is negative 34. All I've done is multiply both sides of the equation by negative 1. So it's still a valid equation. Now, if you add these, you should find that the x's eliminate, as I mentioned. Pause the video and see if you can solve this pair of simultaneous equations. Here's what you should have found. To start with, you should have got 11y on the left-hand side and negative 77 on the right-hand side. So if 11y equals negative 77, then y would just be negative 7. All we're doing to go from this line to this line is dividing each side by 11. Now, that's not the full solution set. That is just a value for y. What we need to do is substitute y equals negative 7 into one of the earlier equations that we had. It doesn't matter which one, but I'm going to choose this one because it seems to have the fewest negative issues to deal with. So if I substitute y equals negative 7 into here, what I end up getting is 2x plus 4 lots of negative 7, so that's plus negative 28, which is just the same as subtracting 28. So I've got 2x minus 28 on the left, and that equals negative 34 on the right. Now, solving this equation here, I get 2x equals negative 6. All I've done there is add 28 to the left and 28 to the right. Dividing by 2, I get x equals negative 3. So my solution set is x equals negative 3, y equals negative 7. Here's the next one. Pause the video and have a go at this one for yourself. Here's how I would solve this one. I would choose to multiply this one through by negative 1. That would give me negative x minus 8y equals positive 6. And I would keep the top equation as it is. So that gives me 3x plus 8y equals negative 2. I would add these together to give me 2x equals 4. That tells me that x equals 2. I would then substitute this into that top equation there. That would give me 3 lots of 2, which is 6, plus the 8y equals negative 2. Subtracting 6 off both sides, I get 8y equals negative 8. Dividing through by 8, I get y equals negative 1. So my solution set is simply x equals 2, y equals negative 1. Here's question D. Now this one's a little bit more complicated because we have x's and y's on different sides of the equation. So it's not immediately suitable for solving by elimination. But it's only one extra step here to collect the x and y terms on one side of the equation and then continue as we've done the earlier questions in this video. So to start with, for this first equation, I'm going to subtract 2y from the left and the right hand side of the equation. That's going to give me 6x minus 2y on the left, and it's going to give me just 11 on the right. Now, on this second equation, if I add 10x to both sides, I'm going to get 10x plus 2y on the left, and that equals 21 on the right. Now, see if you can solve this pair of simultaneous equations for yourself. Here's what you should have found. In this case, we don't need to multiply one of these equations through by negative 1. These are ready to add together straight away because we have a 0 pair here. If we add these together, the y terms will eliminate. I've got negative 2y there and positive 2y there. So when I add, these will eliminate. So adding the left-hand sides, I get 16x, and adding the right-hand sides, I get 32. Dividing the left side and the right side by 16, I get x equals 2. Now I'm going to substitute this one into this second equation, and that's going to give me 10x, which is 10 times 2, so that's 20 plus 2y equals 21. Now subtracting 20 from the left and the right hand sides, I get 2y equals 1, and that means y equals 1 divided by 2, or just a half. Remember, solutions to simultaneous equations don't have to be whole numbers. And in this case, we've got our y value, which is a half. So my solution set is x equals 2, y equals a half.